Hi, everyone. I just wanted to take a minute to talk about what we are going to be doing today. Today, we're going to be dealing with literal equations and formulas. And to start things off, we should make sure we know what a literal equation is and what a formula is. So, that is what you are going to do first. You're going to define literal equation and formula. So, now that you've defined literal equation and formula, let's compare it to the what formula is and what a literal equation is based on the glossary from our book. So, a formula is an equation that states the relationship among quantities. So, you've definitely seen formulas before. One of them, some of the common ones would be area formulas. So, like the area of a triangle is the 1/2 base times height, or if you could have the volume of a sphere, or any sort of interest formula, things like that. Those are pretty common. And then a literal equation is kind of the more general version of that. And it's just any sort of equation expressed in variables. So as you can see here, we have an a, b, and an h. So this is actually a type of literal equation. A formula is a specific like subset of literal equations, except in particular, this is relating quantities, usually kind of some sort of application. Literal equations don't necessarily have to be the relationships among like physical quantities or anything like that. It's just kind of the more general any equation expressed in variables. Okay, so now that we're aware of what they are, let's talk about what we're going to do with them. So ultimately, we're going to be focusing on formulas, and we are going to be rewriting those formulas for a desired quantity. Um, and then we're also going to make sure that we can manipulate formulas to solve various problems in context. And we want to manipulate the formula so that it becomes easier to work with and easier to solve the problems and a little bit more clear. So let's look at our first example. And this is going to be a situation where we're rewriting a formula. So it says Janet wants to calculate the time it takes to earn a certain amount of interest on a principal amount in an investment with simple interest. What equation can she use? So it's telling us right here, Janet wants to calculate the time it takes to earn a certain amount of interest. So that's what we want. We want to calculate time. So that's what we, in the end, want an equation to be in the formula. We eventually want t equals something. And we know it's going to be related to the principal amount. There's going to be interest involved and other things like that. So if we look at what it says here, we have a formula is an equation that states the relationship between one quantity and one or more other quantities. So as we had said, we're going to use the simple interest formula, which is the interest is equal to the principal times the interest rate times the time. And we are going to solve for t, right? We had said that right at the beginning. We want to calculate the time. So we're given this formula. Interest is equal to the principal times the rate times the time. It also then goes on to say and talk a little bit about literal equations, because it is a literal equation because letters represent both variables and known constants. Okay, so it is both, and as we said, formulas are a specific type of literal equations. So all we're doing is we are going to solve this the same way we would solve any other equation. We're going to use the additive properties of equality, the multiplicative properties of equality, in this case, just the multiplicative properties of equality, to solve it the same way you would solve any other problem, right? Because if I gave you a question that said, 4 is equal to 3 times 1 times t, you would all know what to do, right? You would simplify this. You would say 4 is equal to 3 times t, and you would divide by the 3. Divide by the 3. That's all we're doing. We're doing the same sort of steps, except over here, we have nothing that is a specific number that is known. They represent various quantities, however, we don't know what they are. So all we're doing is we're isolating t. That's my goal. I want to isolate t. So to isolate t, I need to divide by everything that is with t. And that's fine because We know that the principal amount we put in is not zero, and we know that the rate is not going to be zero, or there'd be no interest, right? So we can divide by P and R at the same time. I know it looks a little bit weird saying that we're dividing by P and R, but that's okay. As we said, we know they're not zero. Otherwise, we wouldn't be bothering. Um, so you can divide the interest by the principal amount and the rate, and that is ultimately going to give you the time. So again, to reiterate, we did the same steps that we would have done over here. We isolated the t. We isolated the t. The only difference is, as opposed to having 3 and 1, we had p and r, and then we were dividing the interest I by pr, and as opposed to 4 being divided by 3. So that's all we ended up doing. And the reason we might want to do this is, as it states, if we know what the interest, the principal, and the rate are, then it's already in the form that it's going to give us what t is equal to. If we didn't know it in this form, we could plug it in, but then we'd have to go through a number of other steps. And sometimes it's a little bit easier to work with the variables like this as opposed to dealing with difficult numbers, especially in something like this where interest and rates and principal amounts can not necessarily be very nice numbers. So it's sometimes easier to work with dividing out the p and the r as opposed to substituting in values for those. Okay. Let's look at one more example for today. Oh, but before we do that, I want you to try one. So it's asking us to calculate the principal amount. So you want to write the equation that calculates the principal amount. And as a reminder, the equation that you were starting with is I is equal to PRT. And now we want the principal amount. So you can solve that now. All right, so now let's just double check, make sure you're all good with that. We want P, so we want to solve for P, so we have to divide by the rate times the time. Again, this is okay because we know the rate isn't zero or there'd be no interest, and we know the time's not zero or there would be no interest and there'd be no point in this. So the interest over the rate times the time is equal to P. And that's all it is. All right, let's do one more example and then we will end for the day. So now we're going to be continuing on with rewriting and just to solve problems. So we're saying in a half hour, Sarah is meeting her friends at the lake 6 miles from her house. At what average speed must she ride her bike to get there on time? So if we think back to some of the other problems that we had worked on, the ones where the two friends were riding bikes back and forth to each other's houses, or where the bees were traveling from their flower. They were traveling from their hive to a flower. We were dealing with distance, rate, and time. So the formula that relates distance, rate, and time is right here. Distance equals rate times time. And our goal, as it said, what's her average speed? So average speed, if you ever see something like speed or miles per hour or something like that, that is going to be a rate, right? Or, meters per second. Usually anything that is something per something is going to be a rate. So that's how we know we need to solve for a rate. So at the end, we want the r on the right-hand side of the equation, okay, by itself. So now in order to do that, we need to divide by the t again. We know she can't get 6 miles in no time at all, so it's okay that we are dividing by t, then we know it's not zero. Because again, if it was zero amount of time, she clearly wouldn't have gone anywhere. So we can divide by t just the same way we would solve any sort of equation. We're isolating the variable. In this case, we're looking for the rate, okay? So find the average speed or rate at which Sarah must ride her bike on time. So we're given a distance of 6 miles, that is just given to us. And we're also given that it is half an hour. So does it give us what we want the speed in? It doesn't give us the speed, but typically speed would be in miles per hour. So it's usually good to kind of leave this as half an hour or 0.5 hours. There's nothing saying you couldn't do it as 30 minutes and then you'd get miles per minute as your final answer. But just be clear with your various answers to make sure that you get the units to match. Okay, so then you would do rate is equal to distance divided by time. We're plugging in, we know the D is 6. We know that the distance was 6 miles. And then the rate was 0.5 hours. So we have miles divided by hours, or miles per hour. So 6 divided by 0.5, that would be the same thing as essentially 6 divided by 1/2. And when you have a fraction in the denominator, to get rid of that, you multiply by the reciprocal. And what you do to the denominator, you have to do to the numerator. So that would be 12. And as a reminder, it is miles per hour because we're dealing with miles here and we're dealing with hours. Again, if you did it in terms of minutes, it would be miles per minute, but it would be 6 divided by 30 if you did it that way. All right. So finally, you are going to try this one. Sarah is going to the store 2.5 miles away. She only has 15 minutes to get there before they close. At what average speed must she ride to get to the store before they close? So you should try this one now. Okay, so to look over that one that you just tried, let's look at this particular problem. So we're saying Sarah is going to a store 2.5 miles away, only has 15 minutes to get there. So we have a distance and we have a time, and so we're going to be solving for the rate. We know distance equals rate times time. So we are now looking for the rate, so we can divide by the time. Divide by the time, and we get rate equals distance over time. Okay, so now we can plug in what we know. We know it is 2.5 miles. All right, and we are told that it is 15 minutes. So 15 minutes is 0.25 hours. Again, if you wrote it in terms of minutes, you would have miles per minute, which you just have to make sure that you're clear on your notation. I don't know why you would usually, most people don't report anything in miles per minute, but there's technically nothing wrong with that. But you just have to make sure that you are good with your units. Okay, so we have miles per hour. So now we end up in a scenario where we have 2.5 over 0.25. And if we were to do that out, that would end up being 10. You can check that either by converting it into miles per hour. So again, it'd be 10 miles per hour. That's the rate she must go at. But you can check that would be 10 either using a calculator. You could move the decimal places and notice that if we multiplied the denominator by 100, we'd get 250 over 25, which would simplify down to 10. You could convert to fractions, whatever way you would like to solve that. But ultimately, you're going to get 2.5. Okay, that is all for today. I hope you have a great rest of your day.